Resolve is a collaborative project supported by the European Commission, which aims to separate mirror image molecules, a process called resolution. This procedure is critical for many industries, like pharmaceutical, cosmetics, and liquid crystal displays. It is important to separate mirror image molecules called enantiomers because their behavior can be different. The project employed a multidisciplinary methodology to understand their organization on surfaces, enabling the invention of new protocols for their separation with approaches involving tools of nanoscience. Imagine that this glove is a molecule and this one is another molecule identical to the previous one when reflected in a mirror. This mirror image relationship is called chirality. In chemistry, these molecules are called enantiomers and are often mixed with each other in a solution, like a huge sea full of left and right gloves. Imagine now that you are only interested in separating one type. For example, the gloves that fit your left hand. How would you go about it? Self-assembled monolayers using chiral molecules can provide surfaces designed specifically to attract one of the enantiomers in a mixture, or, in your imagination, one of the two types of gloves. This method separates the two forms of the molecule, fixing one of them, the one that interests you, on this surface. Our project aimed to use self-assembled monolayers to act as templates for crystal growth of molecular combinations, called complexes. We created nanoscale spaces in monolayers for recognition. We observed the segregation of enantiomers at molecular level, and we achieved template growth at these nanostructured surfaces. Our results led us to develop rules for the specific attachment of molecules to surfaces. Microcontact printing allows us to mark specific areas of a surface with chiral molecules, similar to a self-assembled monolayer, a SAM. These areas can be visualized as zones of a certain handedness. Imagine that you have huge patterned areas, separated but on a single support. They are surrounded by an environment that repels water like wax, and they are hydrophilic points, which mean they attract water and other polar chemicals. Each of the points is designed to catch one type of molecule specifically, or in our story, different colored gloves. The microcontact printing technique is the procedure that enables you to create all kinds of patterns of enantiomers with varied designs. Resolve employed microcontact printing to pattern surfaces with chiral molecules in order to promote the growth of specific enantiomers. We managed to create unique surface layers with different shapes that have varying ability to make crystals grow. This kind of localized crystallization is useful for the purification of enantiomers. Is it possible to transform a molecule into its enantiomer? Yes, indeed. Think of the example of the gloves. The left glove can be turned inside out and become the right glove, and vice versa. Something similar can happen to molecules in a process called racemization. Often, chiral molecules in solution exist in equilibrium, where both enantiomers coexist, changing into each other. But chemists are usually interested in the properties of only one of them. Imagine you need all the gloves to be right. Due to racemization, all the left-handed molecules can be made right-handed, although all the right-handed will then become left-handed. This takes you back to where you started. So how can racemization be used to make one enantiomer? Easy! You can provoke the crystallization of the enantiomer you want. In this way, you remove the right gloves from the mixture. In order to maintain the equilibrium of 50% proportion in solution, the left gloves will spontaneously change their chirality, becoming right gloves. If you are patient enough, you will see how almost all the gloves become right in the solid, exactly as you wanted. De-racemization was applied to prepare key pharmaceutical drugs made of only one enantiomeric form. The aim was to optimize the drug synthetic route by increasing efficiency and reducing waste. Resolve obtained imantiopure clopidogrel, an antiplatelet drug administered for coronary artery and vascular diseases. This result was achieved by using a variation of the process called attrition-aided de-racemization. This new procedure incorporates the breaking up of crystals in order to act as seeds for the accelerated growth of more enantiopure material.
Hello, my name is Roberto Lazzaroni from the University of Mons in Belgium. Our role in Resolve was to understand through molecular modeling how assemblies of molecules will get together and will interact with each other to form chiral superstructures, and to understand how was the endedness of those chiral superstructures.
Hello, I am Richard Kellogg, project leader for Resolve. At Syncom, we make enantiomerically pure molecules for the pharmaceutical industry and are interested in new resolution strategies. We have contributed our expertise in synthesis and general knowledge of chirality to the RESOLVE project.
Hello, my name is Albert Schenning. I'm working at the University of Eindhoven, and in the RESOLVE project I'm working on chiral molecules that form helical stacks and that can be used to separate enantiomers.
Hello, my name is Racemization. My group at Liverpool look at surfaces under ultra-clean conditions. For example, we use a very precise microscope called the scanning tunneling microscope to observe how chiral molecules like this land on a surface, how they orientate at a surface, and how they pack with each other.
I'm Steven de Veter from the University of Leuven. We use scanning tunneling microscopy to study the separation of enantiomers at surfaces. This technique lets us see molecule by molecule how enantiomers can be resolved.
At the CSIC, our contribution to RESOLVE has been to make chiral self-assembled monolayers and use them for separating enantiomers. We have patterned surfaces, like this one here, to localise the crystallisation of salts of the molecules, and have developed new platforms for resolution.